Hello, in this video, we are going to study about our next concept, that is linear Diophantine equation, solving a linear Diophantine equation. What is this Diophantine equation? What is a linear equation, right? Long back, a scientist Diophantus has said that if there is an equation ax plus by equal to c, right, then we can find at least one solution for this. We can find at least one solution for this using the concept of GCD. Okay, how? If it says that if there is an equation of the form ax plus by equal to GCD of a comma b, right? It means if there is an equation ax plus by equal to c, right? This c is divisible. This c is divisible by GCD of a and b. If c is divisible by GCD of a and b, then we can find out one solution for this equation ax plus by equal to c. You can find out one solution among those infinite number of solutions. For example, if I say 4x plus 3y is equal to 7, for I say, right, there can be multiple combinations of x and y for which this equation might hold true. One equation among those multiple is 1 comma 1, we know, right? If I put x as 1, y as 1, I can get 7, right? So any equation of this form will have multiple solutions. To find out one solution, you can apply the Euclidean algorithm to find it out. Euclidean algorithm to find out the solution, right? So again, if I repeat, what is Diophantine equation? Any equation of this form ax plus by equal to c, right? If it is in linear order, means see x and y's are in linear order, right? They are not the quadratic equations, they are linear equations. Then it is called linear Diophantine equation. And it is said that an equation ax plus by equal to d has at least one solution. It can be found out using this Euclidean algorithm if this c is divisible by GCD of a comma b, right? That is the condition here. Okay, how we solve this? Let us see. So the problem here is very simple. You'll be given an equation ax plus by is equal to d. You have to find out one solution for this particular equation. Though we have infinite number of solutions, we can find one solution. How we find it? We find it using the Euclidean algorithm for finding out GCD. Let's take a simple example and try to solve this. Okay, so assume a equation is given as 47x plus 30y is equal to 1. First you check, first you try to find out what is the first step in this. So this is the question given. The first step here is to find out GCD of, see this is in the form ax plus by is equal to d form. This form ax plus by equal to d form. So I can confirm this, whether it is a linear Diophantine equation or not, we have to confirm that. We have to confirm it first. How do we confirm? First to find out GCD of 47 and 30. Okay, find out GCD of a comma b. We know the approach of finding out GCD using the Euclidean algorithm. How we do? We take quotient, we take a, b and the remainder. So among these two, the largest one will be your a and the smallest one will be your b. Okay, so I am trying to find out the GCD of 47 and 30. So how you do? Divide 47 by 30. So you get 1 here and 17. Next, shift this b to a and r to b. It becomes 30 and 17. Divide 30 by 17. I get 1 here and some 13 here as the remainder. Now you shift 17 this side and 13 this side. It becomes 17 and 13. You divide 17 by 13. It is 1 times. You get here remainder as 4. Now put 13 and 4 here. Right. So 13 divided by 4. 4 3 is 12 and the remainder is 1. Next, shift this 4 and 1 here. So what it becomes? 1 4 is 4 and the remainder is 0. Then shift it back again to the this one becomes 1 and this becomes 0. So whenever the b value becomes 0, a value will be the GCD. So it means GCD of 4730 is 1. Now verify whether this d is divisible by GCD of a comma b or not. Can we divide 1 by 1? Yes, it is divisible. It is possible to divide this d by GCD. Anyhow, both are 1 and 1. So it means we can say that for this problem, there exists, we can find out at least one solution for this. With this conclusion, If D is divisible by GCD of A and B, we can conclude that this is a linear Diophantine equation. Now, using the Euclidean algorithm, using the reverse Euclidean algorithm, we can give a solution for this. How we can do? From this table, you need this table definitely. We have not calculated this simply. We need this table to solve the problem. Okay. Now, from this, you write equations for remainders. You write equations for remainders. So, let us take this first row. In the first row, what is the remainder? 17. So, I can write 17 is equal to, using A and B, make it an equation. So, can I write like this? 47 of 1 into 1 plus 30 into minus 1. I can get 17. I am trying to write equations for remainders using those A and B's, with which I got that remainder. Next equation 13. So, express 13 is equal to, what is value of 13? How can I write it? Can I write 30 into 1 plus 17 into minus 1? If I do this way, I can get 13. 30 minus 17, it is 13. Then the third remainder is 4. So, I have to write it how? Using 13 and 17 and 13. So, 17 into 1 plus 13 into 1. Oh, sorry, 13 into minus 1. I get 4. Then the last non-zero remainder is 1. How can we write this? 1, you write 13 into 1 plus 4 into minus 3. See, this I have just, we are generating equations. Using remainder, we are trying to write equations for A and B. For remainder, we are writing using A and B like this. So, we got 4 equations here. Right. Now, we do reverse substitution here. First, you found out GCD, you wrote this table. Then, you are writing equations for remainders using the A and B's. Okay, we got these 4 equations. Now, do reverse substitution. What is reverse substitution? I will just erase this table here. See, what is reverse substitution? What is the first? Take the last equation. Take the last equation first. Okay, so 1 is equal to 13 into 1 plus 4 into minus 3. Now, you go to the but one equation before the last one, 4. We have a equation for 4. In place of this 4, substitute this whole equation. In place of this 4, substitute this whole equation. So, the equation becomes 1 equal to 13 into 1 plus, what is value of 4? It is 17 into 1 plus 13 into minus 1 whole multiplied by minus 3. Why this minus 3 is already there? Just in place of 4, I wrote this whole equation. Okay, so let us expand this. 1 is equal to 13 into 1 plus 17 into 1 and minus 3. So, don't multiply with the outside one, multiply only with the inner values. Multiply only with the inner values. That is 1 into minus 3, it becomes minus 3 plus 13 minus 1 into minus 3, it becomes 3. Now, what does this equation simplifies to? 1 is equal to 17 of minus 3 plus 13 of 1 plus 3. It is 13 of 4. It is 13 of 4. Now, you go to the one more previous equation. We have a equation for 13. That is 30 of 1, 30 into 1 plus 17 into minus 1. That you substitute in place of 13 here. So, the equation becomes, I just draw a box like this. Now, I am substituting this third but one equation. From the lowest one, the third one, I am substituting it here. So, the equation becomes 1 equal to 17 into minus 3 plus, in place of 13, I will include this. So, it becomes 30 into 1 plus 17 into minus 1 whole multiplied by this 4 as it is in brackets. So, what does this equation becomes? It becomes 17 into minus 3 plus 30 into 1 into 4, it becomes 30 into 4 plus 17 into minus 1 into 4. So, minus 1 into 4 minus 4. So, 17 of minus 4. If I sum it up, it becomes 30 of 4 plus 17 of minus 7. This is my equation now. 1 equal to 30 into 4 plus 17 of minus 7. Now, you go one step ahead, one step previous. If you go, we have an equation for 17. That you substitute it here. So, let me erase this part and write that equation. right? So our previous equation what we got is 30 into 4 plus 17 into minus 7, right? Now you substitute 17 in place of 17, you substitute this value. So this equation becomes 1 equal to 30 into 4 plus in place of 17 it is 47 into 1 plus 30 into minus 1 whole multiplied by minus 7. So if I expand this, 1 is equal to, it becomes 47, 1 into minus 7, it becomes 47 of minus 7 plus 30, 30 of, see, 4 plus 7, it becomes 11. It becomes 11. Now if you observe the question what was given to us, right? If you compare this with the question, we were given 47x plus 30y is equal to 1. So we got the same equation, right? These two things which we derived. From this, x value is minus 7 and y value is 11. Among those infinite number of solutions for this problem, 47x plus 30y equal to 1. Using the reverse Euclidean algorithm, we are finding out that one solution which satisfies this, right? So you can sometimes in competitive exams, if you want to find out one solution for this problem, you can say this, you can use this technique to find out solution. You substitute here, you substitute 47 into minus 7 and 30 into 11, you get 1 as the answer. You substitute and see, you get 1 as the answer, right? So this is linear Diophantine equation, solving ax plus by equal to d, right? Let us see another problem of this equation and try to solve it. Let me give the question. Okay, the equation given to us is 123x plus 45y is equal to 3 is given. Okay, 123x plus 45y equal to 3. Now what you have to do here, first you have to find out the GCD. You have to find out the GCD of this problem. So find out GCD for 123 and 45. Again, I will be doing my Euclidean algorithm to find out the GCD. So how we do? We take Q, we take A, we take B and R. Okay, and I will draw a table like this. So among these two, highest value will become your A. So 123 comes here and 45 comes here. So you divide 123 by 45. So 45 2 is 90. So 2 is 90. The remainder will be 33. You shift this B here and R here. It becomes 45 and 33. So it 33 1 is 33 and the remainder is 12. Again divide 33 and 12. So shift this side. So 12 2 is 24 and the remainder will be 9. Again shift this 12 and 9 here. So if I divide, it is 1 times and the remainder is 3. Now divide 9 by 3. So it is 3 times and the remainder is 0. Shift them here. See, we got 3 and 0. Therefore, we can conclude whenever the B value becomes 0, we can conclude that 3 is the GCD. And this value D is divisible by this GCD 3. This value D is divisible by this GCD 3. Okay, now let us write the equations for the remainders. So what are the 4 equations? 33 is equal to 123 of 1 plus 45 of minus 2, because this quotient is minus 2. Then the next equation for 12, 12 is equal to 45 into 1 plus 33 into minus 1. Next equation for 9, 9 is equal to 33 into 1 plus 12 into minus 2. Same way, let us write equation for this final value 3. 3 is equal to 12 into 1 plus 9 into minus 1. Okay, so I wrote some equations here. Till for non-zero remainders, we have to write it like this. Now I will erase this part. You will apply the reverse Euclidean algorithm by substituting from the lowest one. Keep substituting from the lowest one and find the value. So this is the 4 equations which we got here. Let us substitute. Let's take the smallest equation. What is the smallest equation we have here? 3 is equal to 12 into 1 plus 9 into minus 1. Okay. Now in place of this 9, you see above we have 9. So in place of this 9, you substitute this equation. So this equation becomes 3 is equal to 12 into 1 as it is, plus in place of 9, I will write 33 into 1 plus 12 into minus 2 whole multiplied by this minus 1, this minus 1 as it is. In place of 9, I wrote this equation. So this becomes 3 is equal to 12 into 1 plus 33 into 1 into minus 1, it is minus 1 plus 12 into minus 2 into minus 1, it is 12 into 2. If I write it again, rewrite it, this equation I will just to reutilize this space, I will write it like this. It becomes 33 of minus 1 plus 12 of 3. Just I have added 1 and 2, right? Now you substitute the next equation, go on top, you have equation for 12. Place that 12 in place of this, place this equation in place of this 12. So the equation becomes 3 equal to 33 into minus 1 plus in place of 12 write this, that is 45 into 1 plus 33 into minus 1 whole multiplied by this 3 in brackets. So if I expand this, it becomes 33 into minus 1 plus 45 into 1 into 3, it is 45 into 3 plus 33 into minus 1 into 3, it is 33 of minus 3. If I again write it, solve it and write it, this equation becomes 45 into 3 plus 33 minus 1, 33 minus 3, it becomes 33 of minus 4. Okay, now you go and substitute the final equation. On top you have the fourth equation. So we are substituting from reverse, one on the other we are substituting it. So this becomes 3 is equal to, in place of this 33 I will be putting this equation. So it becomes 45 of 3 plus in place of 33 this one. So it becomes 123 of 1 plus 45 of minus 2 whole multiplied by this minus 4 value. Expand this equation, it becomes 45 into 3 plus 123 into 1 into minus 4, it is minus 4 plus 45 into minus 2 into minus 4, it is 8. Now if you write this equation, it becomes 123 of minus 4, that is 3 is equal to plus 45 of 8 plus 3, it is 11. 45, it is 11. Now you see the question which is given to us, right? It is in the form 123x plus 45y is equal to 3. We got it the same, it is both the equations are matching. Therefore, we can say x value is minus 4 and y value is 11, which satisfies this given condition. So among those infinite number of solutions, this is one solution. This is the one solution for that problem, right? One point I want to highlight here. I am always saying that given an equation 123x plus 45y is equal to 3, I said. When you calculated GCD, the value was 3. Okay, but what if we have an equation which is this is not in the GCD form, like this? If I have 16x plus 6y is equal to 14, for example, I have this way, 16x plus 6y equal to 14. Now you calculate GCD of 16 and 6. You calculate GCD of 16 and 6. Check it is 17 or not. Check it if it is 14 or not. It is definitely not 14, no? We can easily say that the GCD of this is not 14, right? In that case, what we have to do, see, verify. So first find out GCD. First find out GCD of 16 and 6. GCD of 16 and 6. So how will I calculate again? Q, A, B and R. So 16 here, 6 here. 6 2s 12, remainder is 4. 6 comes here, 4. So 4 1s, remainder is 2. 4 comes here, 2. 2 2s, remainder is 0. Shift them 2 and 0. Therefore, 2 is the GCD. Now, is this D 14? Is this 14 divisible by GCD of 6 and 16? That is 2. Is it divisible? Yes, it is divisible. Yes, it is divisible. Right? The 16x plus 6y, it is divisible by this 2, this GCD. Therefore, we can say this equation is a linear Diophantine equation. It's a linear Diophantine equation. Though the GCD is not matching, first the actual procedure is this. You have to first find out the GCD, check if this D expression is divisible by the GCD value. Yes, it is divisible. 14 by 2, I can do it. I get 7 as the answer. Right? Once you get that, you divide the whole equation by 2. You divide the whole equation by 2. That is the second step. Okay, so it becomes 8x plus 3y equal to 7. Now this is your final equation. This is your final equation. Now what you have to do? Find out the GCD of 8 and 3. Okay, that equation now broken down into a smaller equation like this. Okay, so 8x plus 3y equal to 7. You find out GCD of 8 and 3, you get value as 1. You get value as 1. So for time being, you will solve the equation for 1, this one. Okay, write the GCD table using the Euclidean algorithm. Write the table for this equation. We are skipping this 7 now. I am taking the GCD value here. I am converting this equation as AX plus BY equal to GCD of AB. So you write the table for that. What is the table for 8, 3? 8 and 3. So Q, A, B and R. 8, 3. 2's 6, remainder is 2. Then 3, 2. 1's remainder is 1. Then 2, 1. 1, 2's remainder is 0. Then 1, 0. Therefore, 1 is the remainder. So what equations you got? You got only smaller equations. Let's try to solve this. Okay. Right. What we have to do here? Once you found out the remainders, you write equation for the remainders. So I can write 2 equal to 8 into 1 plus 3 into minus 2. Then write equation for the second one. So second remainder 1. 1 is equal to 3 into 1 plus 2 into minus 1. I wrote this. Now do reverse substitution. You take this final equation, the second equation, and substitute in place of 2, substitute this. So the equation becomes 3 into 1 plus 8 into 1 plus 3 into minus 2 whole multiplied by minus 1. So this equation becomes 3 into 1 plus 8 into 1 into minus 1, it is minus 1. 8 into minus 1 plus 3 into minus 2 into minus 1, it is 3 into 2. If I again equate it, this equation becomes something like this. 1 is equal to 8 into minus 1 plus 3 into 3. 8 into minus 1 and 3 into 3. I got this. So now you compare this equation. You compare this equation with 8x plus 3y is equal to 1, which we assumed. Instead of taking this original equation 7, we replace this 7, we replace this d with the GCD. We wrote it like this. So now if I want to convert this equation to this equation, you have to multiply this whole equation with 7. Multiply the whole equation with 7. Okay, so what does this becomes? Again, not the whole equation, but the solution. Okay, so what does it becomes? It becomes 7 is equal to 8 into 7x plus 3 into 7y. What is x here? We got x equal to minus 1, y equal to 3. We got x equal to minus 1, y equal to 3. Substitute here, it becomes 7 is equal to 8 into minus 7 plus 3 into 21. Now you see, after doing all these transformations, what is the equation we got here? We got 8 into minus 7 plus 3 into 21 is equal to 7. This is in the form here. What was our original equation? Our original equation was 16x plus 6y equal to 14. Right? Now you multiply again this with 2. So this becomes 16 into minus 7 plus 6 into 21 is equal to 14. So here x value is minus 7, y value is 21. For this equation 16x plus 6y equal to 14, this is the solution. You can substitute here and see, you will get this answer is satisfying. Okay, so the point which I want to repeat here, if the given question 16x plus 16y equal to 14, if this is not the GCD, then you check whether this is divisible by the GCD or not. If it is divisible, divide it that whole equation, make it a simpler equation. Again find out the GCD. So equation became 8x plus 3y equal to 7. But the GCD was 8x plus 3y, GCD was 1. So I assumed an equation to be 8x plus 3y equal to 1. For that I found out the solution and then multiplied by 7 and then multiplied by 2. I got my final equation for which it satisfies this equation. Right? So this is about linear Diophantine equation solving ax plus by equal to d. Thank you so much.